Software design and software architecture play an essential role in creating software. Without a proper design, the development process gets more complicated over time as the application matures. Today, there are a lot of tools and frameworks which handle the dirty work for you so you can focus more on your business logic. But what about testability? Usually, when designing a new application or even new features inside a bigger software, testability is not always considered a big priority. And even though there are so many books, papers, and articles about good architecture and design, still in many projects, testability plays a minor role during the design phase of a new app or feature. Today I want to tackle these issues by showing you how to ensure testability inside your app and how you need to make design decisions for better testability to create apps that are more maintainable over time. So let's go. Hi, my name is Adrian from codequality.rocks, and this will be the first video of our new series, Introduction into Advanced Unit Testing. In today's video, I want to give you 4 tips for implementing software design and design principles to ensure that your app is testable as much as possible, no matter if it's a small app or a big enterprise application. So imagine you are a member of a dev team, which gets a new greenfield project, where you get the task to write a completely new enterprise application. Let's say it's in the medical field, for example. So time to market should be as fast as possible, and the first MVP is supposed to contain basic functionalities. Due to the environment, the application needs to be tested and it needs to be safe to use, of course. Therefore, you need a good automated testing environment, which runs tests during every build in your pipeline. So you need at least unit tests, some integration tests, and end-to-end tests if possible. Given the short time frame, how do you design complex enterprise applications in this kind of environment and still keep focus on testability and maintainability? How do you avoid having only few tests which make you feel not confident enough to push new code to production because your testing environment is not robust enough? There are, of course, a lot of architecture patterns and design patterns which facilitate testability. The following points, which I am going to talk about right now, can be used as a guideline for future design decisions in any kind of application. One additional information before we start: these tips are mainly focusing on the object-oriented programming paradigm. So let's start with my 4 tips for better testability in your app. Tip number 1. Use a layered architectural pattern for writing and maintaining tests. If we are only focusing on apps containing at least one user interface and manipulate some data, there are so many different architecture patterns out there, like MVC or MVVM, just to mention some of them. What most of them have in common is that they are basically all trying to separate UI, business logic, and database. If we provide different layers and loose coupling, it's much more easy to provide testability for any kind of application. Tip number 2. Use dependency injection. One way to provide more loose coupling is through dependency injection. It is a design pattern and a specific style of the inversion of control principle. It allows us to have loose coupling between classes by using interfaces and base classes to abstract the dependency implementation. Usually a container, also known as DI or IOC container, handles the registration of all the classes. In the end, the dependency is simply injected to the client class. There are 3 types of dependency injection. First, the constructor injection. Second, the property injection. And third, the method injection. I'm now going to show you examples of all 3 types of dependency injection. Just for letting you know, for this demo I'm using the C# programming language and Visual Studio Code as my editor. Alright, let's start with the dependency injection demo. And I just wrote a simple console application which contains dependencies of a hospital service and a message service. And what the hospital service basically does is adding a patient to a list and in the end sending a message via the message service. In this case, it's simply calling a console.writeLine method call. But we can say for this example that the message service is sending a message to another department, for example, to notifying them that a patient was added to, let's say, just some kind of database of the hospital. Going back to the main function, I would like to start with the constructor injection. And as you can see, I have my hospital service instance, and I added another instance of the message service to the constructor of the hospital service. So basically, you would say that you are injecting an instance of the message service into the hospital service instance. Besides the default constructor, I have another constructor in my hospital service which contains a dependency of type message service, and the hospital service class contains a private member, in this case a private field, which is initialized by the constructor parameter, and then you have an instance of the message service in your class, and you can use it inside your class and inside the scope of your class. So in C#, constructor injection is the standard dependency injection type, and most of the IOC containers use constructor injection as the standard way of injecting dependencies. So going on to the property injection example, I am going to comment this line out first of all, because we don't need the first line. We only need the default constructor because we don't want to initialize our private member of type iMessage service via the constructor. We also have a public property of type message service, which we are initializing through the main function. So I'm going to switch back to the hospital service, and as you can see, the message service property inside the hospital service class contains a backing field. This is actually the same private field as we had before, but we are using the default constructor and we are simply initializing the backing field via the property. So what basically happens in property injection, we are initializing the public property of the hospital service through a client class. In this case, it's the program class of the console application. So even though property injection is rarely used in C#, sometimes you might want to initialize your dependencies via property injection. So let's say you don't want to change your constructor, then property injection is a valid way to initialize your dependencies. Going on to the last dependency injection type, method injection. Here you see I overloaded the addPatient method, and the second method contains a second parameter where I injected the message service as a dependency object. Switching to the hospital service, you see that both addPatient methods have actually the same implementation, but the overloaded method contains a message service which calls the send message instead of calling it through the private field. And that's basically it. We are injecting the dependency object through the parameter of the method, and the class does not have to inject the dependency by itself. That's also basically the main reason why you want to use the method injection. If your class does not have the dependency object, or you don't want to have the dependency object in your entire class and you only need it for this particular method, you inject the dependency object as a parameter into your method. Tip number 3. If possible, write the test first. Some prefer writing all the tests up front to have a more client-centric approach. In this case, all the requirements must be well defined. Sometimes this can be pretty difficult because client demand and expectation can change over time. Others prefer test-driven development to reduce the amount of production code and only write as much code as necessary. Test-driven development, also known as TDD, was developed by Kent Beck as a part of extreme programming, and it basically consists of 3 steps. First, write the test for the new functionality you want to add. Second, write production code until it passes the test. Third, refactor the code. I will cover test-driven development in the next episode of the series to give you a more in-depth look. No matter which way you use, try to avoid writing automated tests after your production code. There is simply a higher risk of introducing bugs and implementing unnecessary code when writing tests last, which in the end leads to a higher maintenance cost of your app. Tip number 4. Don't depend on volatile things. This seems pretty obvious, and actually you could see it as the most important rule. Tests that operate through volatile things, like the user interface for example, tend to be fragile. Of course, we know now how to loosely couple different layers of an application and test the business logic without its dependencies. But there's one approach which I would like to talk about: using a testing API. Robert C. Martin introduced in his book Clean Architecture the testing API for the first time. It is a specific API which tests can use to verify all the business rules. The API can be structured in a way that it can bypass security and expensive resources to force the system into a particular testable state. Through this API, you decouple the structure of your tests from the structure of your application. Structural coupling is one of the strongest forms of test coupling. Simply imagine if you have a test class for each production class and a corresponding test method for each production method. There is a high structural coupling, and if you change the production classes and the production methods, all the test classes and the test methods need to be changed as well. With a testing API, you hide the structure of your application from your tests. So you can refactor your production code and it does not affect your tests at all. Of course, it is also the same the other way around. If you want to refactor your tests, it does not affect your production code. So that's it. These are my 4 tips for designing applications and big systems for testability. This list is by far not complete, and there are much more points to consider. But following these rules is a good start to provide a solid foundation for your application. So thank you for watching our first episode of our new series, Introduction into Advanced Unit Testing. And see you in the next one.